Before a single piece of steel ever left Pennsylvania, an insurance company sat down and did the math. They looked at the plans for what would become the Gateway Arch in St. Louis. 630 feet of curved stainless steel, narrowing as it climbed toward the sky. Men who would work on that surface with no nets, almost no harnesses, and none of the safety rules we take for granted today. And they wrote a number into their paperwork. 13. 13 men were expected to die before this thing was finished. That was not fear-talking. That was cold actuarial math, the same kind of math that decides what a life insurance policy costs. We spent weeks digging into what actually happened up there, in the wind that blew between 35 and 70 miles an hour, on a machine that had never existed before this job. Today, we show you the impossible shape that engineers swore could not be built, the climbing crane that built it, and the single final day when 10,000 people stood on the ground, and nobody, not one person, knew for certain whether the two legs would meet at the top. This is the story of the machine that built the Gateway Arch, and the men who rode it into the sky. To understand why this was so dangerous, we have to start with the shape itself, because the shape is the reason everything else was so hard. The Gateway Arch appears, at first glance, to be a simple curve. It is not. It is something called an inverted catenary. Take a chain, hold it by both ends, and let it hang loose. The droop it forms is a catenary curve. Now flip that exact shape upside down. That is the arch. It is the one curve that supports its own weight perfectly, the load flowing straight down through the steel into the ground, with no part of it trying to bend or snap. The architect who chose that shape was a Finnish-American named Eero Saarinen, and he won a national design competition back in the late 1940s, beating out 171 other entries, including pyramids and giant fountains, and one design that looked like a row of enormous croquet hoops. Saarinen wanted something simple and timeless, a gateway you could imagine the pioneers passing through on their way west. But here is the part most tellings of this story get wrong, and it matters. Saarinen designed how the arch would look. He did not work out how it could actually stand up. That fell to a structural engineer named Fred Severud and his associate, a man named Hans-Carl Bandel. Bandel was the one who refined the curve and ran the calculations that made it buildable. A lot of documentaries credit the wrong man for this. Severud's own son said it plainly years later. Without his father's firm, there would be no arch today. Saarinen never saw any of it. In 1961, he was diagnosed with a brain tumor. He died that September, at the age of 51, during surgery. Construction did not begin until February of 1963. The man who dreamed up the most recognizable monument in the American Midwest never watched a single piece of it rise. Now, the shape created a problem that had no easy answer. The arch has what engineers call an orthotropic design. That is a heavy word for a simple, almost unbelievable idea. There is no skeleton inside. Most skyscrapers go up as a steel frame first, and then the walls and windows hang on to that frame. The arch has nothing of the kind. The outer skin of stainless steel and the inner skin of carbon steel, with concrete poured between them in the lower third. That skin is the entire structure. It is hollow, like a stalk of bamboo, and the walls carry every ounce of the weight down to the foundations. Which sounds elegant, until you ask the obvious question. How do you build a hollow curve that leans further and further out over empty air, with no frame to hang scaffolding from, and no way to prop it up from the inside? You build it as two separate legs, two freestanding towers, each one curving inward toward the other, each one rising on its own, completely unsupported, until the day they are supposed to meet in the middle, 630 feet up. If the math was wrong, even by a fraction, the legs would miss. And there was a real chance of exactly that. People in St. Louis drew cartoons of the two legs sliding past each other and just kept growing into the clouds, never touching. That was the joke, but underneath the joke was a genuine fear. Nobody had ever built anything quite like this. If you are enjoying this so far, take a second to subscribe, because we dig into the forgotten machines behind America's greatest structures every single week, and we have a lot more of these stories coming. Now, before the legs could rise an inch, the crews had to dig down. The foundations go 60 feet deep, 30 of those feet sunk into solid limestone bedrock. Nearly 26,000 tons of concrete were poured to anchor the legs, laced with steel tensioning rods. Think of it as a 6-story building made of solid concrete, buried underground, just to hold each foot of the arch in place. With that done, the real climb began. And that is where the machine comes in. The crews started with ordinary cranes, the kind you would see on any big construction site. And the cranes worked fine, right up until they ran out of reach. At 72 feet, about 6 stories, the conventional cranes were finished. There was no crane on Earth tall enough to lift 50-ton sections of steel up to where this arch was going, which was more than 10 times higher than that. And you could not build a scaffold tower next to it, because the legs curved away from vertical as they rose. The engineers were standing in front of a problem nobody had solved before. So they built something the world had never seen. They called it the creeper derrick. Here is how it worked. And it is genuinely one of the most clever pieces of construction equipment ever put to use. Each creeper derrick was a massive assembly, well over 100 tons, with a crane mounted on top that reached about 130 feet. But the derrick did not sit on the ground. It rode on a set of railroad tracks that were bolted directly onto the side of the arch leg itself. As the leg grew taller, the derrick climbed it. Cables and pulleys hauled the whole machine up the curving steel. Once 4 new sections were installed above it, workers would bolt on another length of track, and the derrick would pull itself up to the new height and keep going. It was a crane that climbed the very thing it was building. 2 of them, one on each leg, working at the same time. The company that fabricated the steel and ran much of this work was the Pittsburgh Des Moines Steel Company, and they were proud enough of the job that they painted their initials, P, D, and M, in large letters on the side of one of the derricks, where everyone could see them. The National Park Service was not having it. This was a federal monument, they said, not a billboard, and they ordered the letters removed as illegal advertising. The company pushed back at first, until they learned what it would actually cost to strip and repaint the lettering. $225,000, plus another $42,000 a month. Faced with that bill, they relented. It is a small detail, but it captures the strange collision happening on this site every day. A private steel company and the federal government arguing over paint, while men hung off the steel above them, risking their lives. But the curve created another headache. As the legs leaned inward, the derrick's platform would naturally tilt with them. A tilted crane platform is a recipe for disaster. So the engineers designed the platforms to adjust, tilting against the slope to stay level no matter how far the leg had curved over. The men working up there were standing on a machine that was constantly correcting its own angle, hundreds of feet above the Mississippi River, on a structure that swayed in the wind. And the sections they were lifting were not small. Each triangular piece, what the workers actually called a can, weighed around 50 tons and was hollow inside to leave room for the tram system that would one day carry visitors to the top. There were 142 of these cans in total, 71 stacked up each leg, and every joint between them had to be welded so perfectly that the whole thing behaved like one continuous piece of metal. Now think about who was doing this work and how. These were ironworkers, welders, and surveyors, walking on curved steel 600 feet in the air, in an era before the federal safety agency we know today even existed. There were no guardrails on most of it. Many of the men were not wearing harnesses at all. One field engineer who was there described it bluntly years later. The men walked on bare scaffold boards with almost no safety protection, and many of them smoked cigarettes while they did it, hundreds of feet above the river. He added a line that says everything about that time. If they were afraid, they did not stay very long. One of those men was an ironworker named Don Horton, 25 years old. Horton worked out on the open edge of the steel, hundreds of feet up, leaning his body over empty air to tighten a bolt with a wrench on the end of a long pipe for extra leverage. He held on with one hand, gripping nothing more than a steel ladder rung. No harness, no net below him. When asked years later why men would do work like that, his answer was not about glory or pride in the monument. It was about survival. They were just trying to keep the wolf from the door. That was the Depression-era logic still running through these men. You took the dangerous job because the dangerous job fed your family. Then there was Clarence Cherry. Cherry was a weld inspector, and his job was to make sure those critical welds between the cans were sound. He did it by X-raying them, often at night, which meant handling radiation equipment so dangerous that everyone else had to clear the area while he worked. He followed procedures borrowed from the Atomic Energy Commission, roping himself off with radiation warning signs. And because the wind up there blew anywhere from 35 to 70 miles an hour, Cherry tied himself to the steel like a mountain climber, so he would not be blown off. One day, a welding rod broke off and hit him square in the mouth. He was taken down to the hospital, got 6 stitches, and then he went back up and finished his shift. That same night, in a rainstorm. When he told that story decades later, he was 91 years old, and he told it like it was nothing. Just a day on the job. Not everyone could handle it. The same crews watched men climb to a certain height, look around, and decide they were done. They would say, "That is it, no more," and they would quit on the spot and never come back. You cannot blame them. The wind would get so strong on some days that the entire crew had to climb down and wait it out, because the legs were moving too much to work safely. One worker remembered a single day when it got so bad up top that everyone had to get off the steel. It is worth pausing on just how exposed these men were, because 30 years earlier, on the other side of the country, the builders of the Golden Gate Bridge had strung a giant safety net beneath the deck, and that net is credited with saving the lives of 19 men who fell into it. The Gateway Arch had nothing like that. There was no net stretched across the gap between the legs, no soft landing waiting below. If you came off the steel here, there was only the ground, hundreds of feet down. The men knew it, and they walked the beams anyway. There was also a quieter kind of tension running through the whole city while this went up. People genuinely placed bets on whether the two legs would meet. One young apprentice, barely out of his teens, supposedly took a $10 bet that he could run up the emergency stairs inside a leg in time to watch the final piece go in. $10 was real money to a kid earning a couple of dollars an hour. That was the mood. Equal parts wonder and doubt, with money on the line. And there were lighter moments too, the kind that only happen when men spend months living on a job like this. At one point, around 480 feet up on a rising leg, a barber actually came up and gave one of the ironworkers a haircut, right there on the steel. The men joked that it was the highest haircut in the city of St. Louis. It is a small thing, but it tells you how these crews turned an impossible, terrifying job into something they could live with, day after day. There was one moment during construction that had nothing to do with steel or welding, and we should mention it because it became part of the arch's history. In July of 1964, two civil rights activists named Percy Green and Richard Daley climbed about 125 feet up the unfinished north leg to protest the lack of black workers on the project. They stayed up there for around 4 hours while a crowd gathered below, and the demonstration drew national attention to hiring practices in the building trades. It eventually fed into a landmark legal case. They climbed down on their own, and the work went on. But for those few hours, the most ambitious construction site in America came to a complete stop. By the time both legs had climbed past 500 feet, the engineers were facing their most dangerous moment yet, and it had to do with the weight sitting on top of those legs. Each freestanding leg now had a 100-ton creeper derrick perched near its summit, plus the weight of the steel itself, all of it leaning inward over empty air. The legs were starting to want to topple toward each other. They were, in the words of one observer, rocking and rolling up there in the wind. The solution was a temporary steel brace called a stabilizing truss, a piece 60 tons in weight and nearly as long as a football field, that had to be installed horizontally between the two legs at the 530-foot level to hold them apart and steady until the final pieces could go in. Lifting that truss into place on June 17, 1965, was one of the most delicate operations of the entire project. Both creeper derricks had to lift their ends of the truss at exactly the same rate, in perfect synchronization. If one side got ahead of the other, the load would shift dangerously onto a single derrick. And here is the detail that makes it remarkable. The two derrick operators could not see what they were doing. They sat in control shacks set back behind the legs, working blind, taking commands over walkie-talkies from spotters who could see the truss. The night before, the crew had marked the lift line in 10-foot increments, like a giant measuring tape, so they could track exactly how high each end had risen. Two men, blind, lifting a 60-ton beam the length of a football field, more than 500 feet in the air, by voice command alone. They got it level. They locked it in, and the arch held. With the truss in place, the crews could add the final 21 sections to each leg and close in on the top. But there was still one problem nobody had solved, and it had been hanging over the project from the very beginning. How do you get visitors to the top of a hollow, curving structure that gets narrower as it rises? An elevator goes straight up and down, and the arch does neither. An escalator could not handle the curve either. The engineers were stumped, and the man who finally cracked it was not a famous architect or a celebrated engineer. His name was Dick Bowser, and he was a second-generation elevator man from Des Moines, Iowa, with no college degree at all. Bowser was given 2 weeks to come up with a solution. 2 weeks for a problem that had stumped the experts for years. He went home and worked it out in his own basement. His answer borrowed from the Ferris wheel. Instead of a car that goes straight up, he designed a string of small barrel-shaped capsules linked together, each one able to rotate and stay level as the whole train climbed the curve of the leg, exactly the way a Ferris wheel keeps its seats upright, no matter where they are on the circle. When he presented the idea, one official tried to question his qualifications and asked him, point blank, "Mr. Bowser, what are you?" Bowser, with no degrees to list, simply said he was 38 years old. The room laughed, and as he put it later, that was the end of his credentials. His tram system still carries visitors to the top of the arch to this day. 5 small capsules to a car, just enough room for a few passengers each. A man with no diploma solved the problem the professionals could not. If you are getting something out of this, hit that subscribe button. We tell the stories of the forgotten engineers and the impossible machines behind America's landmarks, and we put out new ones every week. Now we come to the final day, and everything came down to a few hours under a bright October sun. By October of 1965, the 2 legs of the arch reached toward each other across a shrinking gap at the very top. The completion was a public event. People in St. Louis had watched this thing rise piece by piece for 2.5 years, and now they wanted to see it finished. The final section, the last triangular can that would close the gap at the top, was scheduled to go in, and the whole city was holding its breath. Newspapers had run cartoons showing the 2 legs sliding past each other and missing, climbing forever into the clouds without ever touching. And that fear was still very much alive. Nobody had ever joined 2 freestanding curved steel legs at 630 feet before. The tolerance for error at the top was almost nothing, a fraction of an inch. The engineers had been fighting an invisible enemy the entire time they built the upper sections, and that enemy was the sun. When sunlight hit one leg and not the other, the warmed steel would expand, and the leg would actually bend out of position by as much as a foot. A foot of movement, when your margin for error is a fraction of an inch. To get accurate measurements, the surveyors had done much of their critical work at night, when both legs were the same temperature, using precise instruments called theodolites and 4 fixed monument points set in a rectangle around the base to triangulate the exact position of the steel high above. They would sight the north leg from the southern markers and the south leg from the northern ones, and apply the rules of trigonometry to pin down any point on the curve. Accuracy had to be held to within 1/64th of an inch. Consider what that means. A structure 63 stories tall, 2 legs built completely separately, and the men aiming them at each other were working to a tolerance thinner than a dime, doing their most important measurements in the dark to beat the heat of the sun. But on the final day, in broad daylight, with 10,000 people watching, the sun was beating down on the south leg, and that leg was expanding and leaning, closing the gap they needed to slide the last piece into. The crews had originally planned to top out on a Saturday, but officials grew nervous. There was 100 feet of stainless steel sticking up with a heavy derrick perched on top, and a bad windstorm at 600 feet could put the whole vulnerable structure at risk. So they moved the date up 2 days, to Thursday, October 28th. That morning, the sun was already at work on the south leg. The expanding steel had narrowed the gap by 5 inches. They needed the opposite. They needed to force the legs apart to make room for the final piece. So they called the St. Louis Fire Department. Fire crews ran their hoses up the south leg and sprayed it down with cold water, as high as they could reach, to cool the steel and stop it from expanding any further. Workers up top described the water pouring back down off the leg, like a little Niagara Falls. The cold water tempered the south leg, but it was not enough on its own. The legs were still leaning too close together. So the engineers brought in hydraulic jacks, enormous ones, and used them to physically pry the 2 legs apart. By the accounts from the arch itself, those jacks applied over 500 tons of force to spread the legs and open up the gap, widening it by several feet so the final section could be lowered into place. 10,000 tons of steel, being pushed apart by machines, so that one last piece could fit. And here is the part that has always stayed with us. The man operating the derrick that lowered that final piece into the gap could not see it go in. He was in a control shack set back about 100 feet behind the leg. He had no view of the top of the arch at all. Everything he did by listening to commands relayed over an intercom. 2 inches to the right, 2 inches to the left. He was balancing a piece of steel weighing several tons, 630 feet in the air, into a slot with almost no margin for error, and he was doing it completely blind, guided only by a voice. A priest and a rabbi said prayers over the final section before it went up. And then, after a few tense moments, with the whole city watching, the last piece settled into place, and the welders moved in to lock it down. The 2 legs met. The math had been right. The arch was closed. Take a breath, because that single moment was the payoff for 2.5 years of work that had no margin for error. If you have watched our other films, you have seen this pattern before. The men who built the Empire State Building raced steel into the sky in just over 400 days, and the deadliest machine at the Hoover Dam turned out to be nothing more than a steel cable. The arch belongs in that same company, a project where the engineering was so far ahead of its time that the people watching genuinely did not know if it would work. If stories like this are why you are here, do yourself a favor and subscribe so you do not miss the next one, because we have many more of these coming. Now, there is one more myth about this final piece that we need to clear up, because the careful eyes in this audience have probably already spotted it. Now, you will often hear that last piece called the keystone, and there is a story worth telling here, because it is one of those details the careful viewers among you will appreciate. In a traditional stone arch, the kind the Romans built, the keystone is the wedge-shaped piece at the very top that locks all the other stones in place and carries the load. The gateway arch does not really work that way. It is a welded steel structure, 71 cans up each leg, and they simply meet at the top along a weld line. There is no single wedge-shaped stone holding it all together. The photographer who had the only permanent access to document the construction noted exactly this. Each leg consists of 71 cans, which meet at the top in a weld line, and there is no keystone piece. People call the final section the keystone because it is the dramatic last piece, and that is fine as a name. But if you want to be precise about the engineering, the arch holds itself up through that perfect catenary curve and those continuous welds, not through a keystone the way an old stone bridge does. Sealed inside that final section, by the way, is a time capsule containing the signatures of more than 760,000 St. Louis school children. And now we come back to that number from the very beginning. 13 men, the insurance company predicted, would die building this. So how many actually did? None. Not one worker died during the construction of the Gateway Arch. The project manager later said the crews went 500 days without a single lost time accident. 500 days of men walking curved steel in 70-mile-an-hour wind, with no nets and barely any harnesses, X-raying welds in the dark, riding a crane that climbed the side of the structure, and not one of them was killed doing it. When you sit with that, it is genuinely staggering. Some of it was the skill of these particular men, the elite ironworkers and welders who were described by one of their own as the doctors and surgeons of the trade. Some of it was the way the crews were kept small and the work areas tightly controlled, and some of it, honestly, was luck. But the prediction was 13, and the result was 0. That is the real monument here, as much as the steel itself. The men who built the most dangerous structure in America at the time all went home to their families. It took the better part of a year after the topping out to finish the job. The two creeper derricks, those one-of-a-kind climbing cranes, had to be slowly walked back down the legs they had climbed, cleaning and polishing the stainless steel as they descended. The stabilizing truss was removed, and for the first time, the arch stood entirely on its own, holding its own weight exactly as Bandel's calculations said it would. The tram that Dick Bowser designed in his basement did not open to the public until 1967, and the full dedication did not happen until May of 1968, when the vice president stood in a downpour to mark it complete. The final cost was around $13 million, which is close to $100 million in today's money. The arch was built to sway. In high winds, the top can move more than a foot in each direction, and people who ride to the observation deck on a windy day can feel it shift under them. That is not a flaw. That is the design doing exactly what it was meant to do, flexing instead of fighting. The same principle that let those legs survive 2.5 years of standing free in the wind before they were ever joined. For all the danger during construction, the arch did not actually take a life until long after it was finished, and the story of how it finally did is a strange and sad one. In November of 1980, a man named Kenneth Swires parachuted onto the top of the arch. The plan, apparently, was to land on the summit and then base jump off and parachute down. But a gust of wind caught him, pushed him onto the curved surface of the north leg, and his reserve chute failed to save him. He slid more than 600 feet down the polished steel to the ground. His wife was filming from below. He remains the only person ever killed by the arch, and he died not building it, but trying to conquer it for a stunt. Years later, another man managed to climb the north leg using suction cups and then parachuted off and survived, the only person to ever live through a jump from the arch, and he was promptly arrested for it. So the Gateway Arch stands there today on the bank of the Mississippi, catching the sunrise on one face and the sunset on the other, and it is worth remembering what it actually is. It is not just a beautiful curve. It is the product of a shape that experts swore could not be built, calculated by an engineer almost nobody has heard of. It is the work of a climbing crane that had never existed before and was never quite needed again in the same form. And most of all, it is the work of men who tied themselves to swaying steel 600 feet in the air, took a welding rod to the face, and went back to finish the shift, and walked those curved beams with the wolf at the door and their families at home. 13 of them were supposed to die. All of them lived. If you found this story worth your time, do us a favor and subscribe, because every week we bring the forgotten machines and the forgotten men behind America's greatest structures back into the light, and there are a lot more of them still waiting to be told. We will see you on the next one on the screen.